Air pollution tends to get a lot of the attention, maybe most of the attention when it comes to climate impacts on health. Obviously, under global warming, climate change, anthropogenic forcing, and so on, air pollution is one of the most obvious outcomes of fossil fuel burning as well, in addition to the increases in greenhouse gassing and the associated warming, sea level rise, glacier melts, extreme events, and so on. So this chapter, called Ozone, Oppressive Air Masses and Degraded Air Quality, focuses on the various aspects of air pollution impacts on health. As you noticed, we have not really done end-to-end kind of introduction here, in the sense we have looked at climate change, health, and kind of empirical relations based on which we find that there are relations between variabilities and trends in various environmental variables like temperature, precipitation, and extreme events like floods and droughts on health outcomes, right? That's kind of the theme. There are clinical aspects. We will look at some clinical correlates soon. I have been skipping them. Each chapter has clinical correlates in the book that I will summarize soon. Okay, so what are the sources of pollution? I think we all know what pollution is. It's something that degrades air quality, and outdoor air pollution and indoor air pollutions are two things, and the activities involved are also quite different in generating outdoor air pollution and indoor air pollution. Of course, there are commonalities in terms of burning biomass and so on. Outdoor air pollution affects urban and rural areas and is caused by multiple factors. Industry, energy supply is one of the biggest contributors, especially cement and coal burning and cement production and coal burning. Of course, transportation, fossil fuel consumption is mostly for transportation. Waste management, so either burning land by land dump sites for waste where methane gets emitted, for example, and dust, which can be because of directly human activities like construction and so on, but also because of human-related climate changes like droughts and deforestation, agricultural land conversion, and other land uses, right? Agricultural practices themselves generate lots of pollution as well, not only in the air but also for water, as we talked about, nutrient pollution and so on. Household energy consumption, of course, and we have to remember that countries cannot tackle air pollution alone. It's a global challenge. We must all combat it together. This is from World Health Organization and its informatics infographic shown here. You see many types of these brochures, or whatever you want to call them, where we look at effects of air pollution on health with some numbers. Like here, 7 million people die every year from air pollution. These are additional deaths or premature deaths because of air pollution. So you have to be able to attribute the cause of death to air pollution for ultimate mortality. Main causes of air pollution, as we saw already, listed here: aerosols, radiation, forest fires, transportation, and industry. And I won't go through all of the, well, maybe we'll just go through these. Air pollution impacts include hair damage, which has become quite common now, eye and mucous membranes, so that is related to various factors like sulfur dioxide emissions, NOx, and CO2, of course, and acidity in the air. Respiratory diseases also caused by the various pollutants. Liver, spleen, and blood damages related to NO2. Bone damage. So there are tropospheric ozone, particulate matter PM, sulfur dioxide, nitrogen dioxide, and benzophosphine BAP listed here as the main pollutants, and the various sources are implied again here, including some suggestions of how to improve. So in order to avoid air pollution, we need to reduce harmful emissions and promote the use of renewable energies. So it's showing renewable energies, people biking, taking public transportation, and so on. But coming back to the various diseases, we have had fatigue, headache, anxiety, nervous system damages, cardiovascular damages, skin damage, which is related also to hair damage, intestinal damage, reproductive system damage, and so on. So these are serious issues. So there are the sources, and then there is the interaction with the environment itself. So circulation, and the pollution gets transported long distances, so there is dispersal of pollution, and there is chemical transformations as well that we have to worry about. For example, lower tropospheric ozone, which unlike the stratospheric ozone is very harmful for human health and other things like crop production, as we will see, it results from chemical transformation of the ozone precursors like NOx, nitrogen oxides emitted from vehicles, and methane, volatile organic carbons, and non-methane volatile organic compounds. Okay, so here are particles and vapors emitted from source, uptake by leaves, so atmospheric deposition happens. It could be dry deposition, heavier particles just settling down, causing ingestion of contaminated plants and soils by herbivores, uptake by plants and soil invertebrates, transfer up terrestrial food web through birds and so on, consumption of fish by birds, and direct absorption and settling into the water bodies, uptake by benthic organism, transfer up the food web, consumption of contaminated water by various animals, and uptake by also aquatic animals, not aquatic plants, not just terrestrial plants. And there is also so-called wet deposition, where cloud properties themselves are transformed by pollution. We talked about it a little bit. Aerosols can act as cloud condensation nuclei and cause drizzle rather than rain, can actually change the amount of rain that falls, can change cloud optical properties and make them brighter. Black carbon can be absorbing aerosol that heats up the air, and so on. So here is another infographic showing air pollution from emission to exposure, which is what we mean by transport and chemical transformations. So man-made or natural resources are producing pollutions, with road transports contributing 20% of the EU's total emissions of CO2, for example, more than 30% of NOx emissions in the EU coming from road transport, and around 12% of the EU's PM 2.5, particulate matter 2.5, so 2.5 micrometers or smaller, which can directly go into the lungs, into the bloodstream, even into the brain, and so on, and have been found to be causing serious issues all the way into diabetes, mental problems, and inflammations, and so on. So the different pollutants are emitted, they are transformed chemically, and there is also photolysis, so reaction to sunlight, and they are dispersed, impacting the weather, and they also impact topography, and of course impacts on people and the environment. Okay, so we have to worry about not just health, which is what the main focus here is. So indoor and outdoor air pollution is linked to 7 million premature deaths, as we just mentioned, but we also have to remember that some air pollutants after climate change affect climate change and accelerate Arctic warming and glacial melt. okay, because of the circulation. Especially the ones that get into the stratosphere tend to make it all the way to the poles and get into the polar vortex and accelerate Arctic warming and glacial melt. Air pollution affects rainfall patterns, storm intensities, regional weather patterns such as the monsoon. Haze and dust from air pollution can reduce solar yields by as much as 25%, so renewable energy impact. And that also affects crop yields, by the way. Air pollution reduces global crop yields by up to 15% for wheat and soy and 5% for maize. Okay? So we'll come back and look at some other feedbacks. For example, here is the increases in air conditioners sold over 2012 to 2017 for various regions: total Americas, total Asia Pacific, total Europe, total Middle East, India, and Africa. And you can see that Middle East, India, and total Asia Pacific here, China and the other countries, the numbers have been shooting up because the warming is easily dealt with by buying more air conditioners, which emit strong greenhouse gases like HFCs now. CFCs are banned, but HFCs, which are very damaging in terms of global warming. So there is a feedback again. So warming makes people, especially the economically growing countries like India and China, people want to buy air conditioners, but air conditioners make the global warming much worse. So this is the kind of, and there are pollutants coming from air conditioners as well. Okay, so we are in this wild loop that we are churning more pollution, affecting health, and the air pollution affects climate in turn, and we are going to have to plan mitigation and adaptation actions based on these kinds of information. The sources we already mentioned, for example, renewable energies, public transportation, bicycling, and so on. These are going to reduce not only greenhouse gases but also pollution and improve health. So those are the kind of things we will discuss a little bit more as we go along by looking at specific relations of various types of pollutants and health. Okay.